Good evening, grade 8. Tonight's lesson will be on 1.6, exploring the Pythagorean theorem. So basically we're going to take all our schema, prior knowledge, and about Pythagorean's theorem and use it in today's lesson. Basically what's going to happen today is I'm going to give you three triangles right here. You'll see the triangles right here in blue, green, and let's call this red over here. Basically, we're going to use our knowledge of Pythagorean's theorem. We're going to figure out if any of these triangles, the red, blue, or green ones, would be an example of a right triangle, because remember, Pythagorean's theorem only works when we have a right triangle or a 90-degree angle as one of our angles in our triangle. So our knowledge we'll use our previous knowledge, our schema, to figure out if any of these work with Pythagorean's theorem. And if it does, it's a right triangle. And then what happens if it doesn't work with Pythagorean's theorem? Can we use that new knowledge to identify what kind of triangle it would be? Because there's different types of triangles, and you'll learn by the end of this lesson the names of a few different types of triangles. Okay, so let's take a look here at the triangle in red. Okay, so we have one length as 6 centimeters, one is 8, and one is 9 centimeters. Now they've gone and drawn these squares for you already, which is nice. Thank you, textbook. So let's take a look. The longest side is always the hypotenuse in a right triangle. So let's see if this red one meets the requirements of Pythagorean's theorem. So we take the area of our two legs, in this case 36 and 64, and if we add up 36 and 64, that should equal the area of our hypotenuse if it is a right triangle. So in this case, 36 and 64 equals 100, and if you notice, the area of the hypotenuse is only 81. So I can tell you right now that this red triangle is not a right triangle because it does not fit the Pythagorean theorem. Let's go over here to the blue one. Same thing, we have a side length of 6, a side length of 8, and a side length of, this time, 10 centimeters instead of 9. Okay, well, the square here, 36 plus 64, so 36 plus 64 is 100, and guess what? The area of our hypotenuse is 100. So that tells me it fits the a squared plus b squared equals c squared model, which is Pythagorean's theorem, which means that this angle right here is a right angle or 90 degrees. And you can tell actually it has a little square there, and that's the giveaway that it's 90. So the blue triangle right here is a right triangle. Well, let's look over here at the green example. Base of 6 centimeters, another leg here of 8 centimeters, and then the hypotenuse is 11 centimeters. So 36 plus 64 we know is 100. In this case, the green area is 121, so it's actually more than 100. Okay, so this would not be an example of a right triangle. Check this out. As I scroll down, they have done something here. They have taken the area of the longest side, in this case 81, 100, and 120, and they put it in this little chart here. And you know what? Anytime you add up the area of your largest square, and if it's less than the Pythagorean theorem, we are going to call it an acute triangle. So this one here, this red triangle would be an acute triangle. What I always think of is if every angle is less than 90 degrees, in this case it is, they're all smaller, they're acute. And so this would be an example of acute triangle. And the reason we know that it is when we add up the two smallest legs, the area of the two smallest legs, it's less than the number. So it's less than 100. So we know it's acute. Over here, take a look here. When you add up the area and it's larger than Pythagorean's theorem, in this case, the green square added up to 121, which is larger than 100, we call that an obtuse triangle. Now, what an obtuse means is that one of the angles in the triangle is greater than 90 degrees. So you can see this angle right here where my cursor is actually goes past 90 degrees, and it looks like it maybe be around 100 degrees. So when one angle in your triangle is greater than 90 degrees, we call it obtuse. And the easy way to tell is when you take the area of the square off the two shorter legs, and if it's greater than, in this case, 100, we know it's obtuse. All right. Okay, so now we're going to go look at an example here. Here's a triangle. I'm not sure if it's a right triangle. It's given me the dimensions here. This side is equal to 6, this side is equal to 6, and this side's equal to 9. Now, what I need to do is I use Pythagorean's theorem. So I draw my square off each side. You might notice it doesn't look like it's to scale here. We just got to ignore my terrible drawing and do our best using Pythagorean's theorem. So take a look here. What would the area off of this side length be? Well, if one area is 6, we know 6 times 6 is 36. Same thing over here, one area is 6, so 36. So 36, so if I take the area of the two smallest squares, so 36 plus 36 is equal to 72. So if this is an example of a right triangle, this area here should equal 72. Well, I know 9 times 9 is equal to 81. So I know that this is not an example of a right triangle, and I also know that since 81 is bigger than my 72, that means that this would be an obtuse triangle. Alright, so I'm going to give you one example. I'm going to leave you with one example here, and I want you to tell me if it is an example of a right triangle, an obtuse triangle, or a acute triangle. Let's go draw you a triangle right here. Okay. This has a side length of 3. This has a side length of 4. This has a side length of 6. There's your question. Comment on Edmodo. Tell me right triangle, acute triangle, or obtuse. Good luck. We will meet tomorrow after lunch and go through some more examples. All right, grade 8s. Thanks a lot. Have a good night.